We're gonna be doing question 5 of week 6A homework. So, today we're looking at this question, which is asking us which type of lens produces a virtual image that is inverted with respect to the object. So, before we pick an answer, let's just write down our variables and like our formula that we're dealing with. So first we have DO, which is the object distance. So DO is the object distance. And so it's basically how far the object is from our lens. And so it's measured in meters. Then we have DI, which is the image distance, which is also in meters. Distance is also in meters. And so if DI turns negative, that tells us that the image is virtual. So next we have F, which is the focal length in meters. F, focal length in meters. And so for the height, we have HO, as I wrote here, for object height, and HI for image height. So both of them are in meters. And then lastly we have M for magnification. And it tells us how big or upside down the image is compared to the object, and magnification doesn't have any units. So the main equation connecting these is 1 over the focal length is equal to 1 over dO plus 1 over dI. And to figure out orientation and size, we use the magnification formula, which is M is equal to negative dI over dO. And the negative sign is for the entire equation, not interesting. And so that is also equal to HI over HO. And so to break down how this works, um, oh wait, actually the negative sign is only for DI, my bad. So to break down how this works mathematically and conceptually, for an image to be virtual, DI has to be negative or less than 0, and for an image to be inverted or upside down, the magnification M must be less than 0, 2, or negative. So if we plug in a negative DI into our magnification equation, which is this one, we would get magnification is equal to negative DI over DO. And since DO is always a positive number, in single lens setup, a negative DI makes the double negative turn positive, so then it would be positive DI over DO. Um, and so a positive magnification means the image is upright and not inverted. So if we look at a conversion lens, when an object is closer than the focal point, um, it makes a virtual image, but as you can see in my drawing, it's right side up, right side up. So, it's right side up, and with a diverging lens, it only creates virtual images, but they are always upright and smaller as well. So, can a single lens ever make a virtual image that is upside down? No, it can't. And so the math shows us that the virtual images from single lenses are always upright. And so therefore the correct choice is neither a converging nor a diverging lens produces such an image, as you can see. Thank you.